Good morning, Olivia. How are you today? Okay, I just unmuted you.
Good morning. I'm good. How are you?
I'm wonderful. I'm so glad somebody was here. I was wondering if I should just teach the lesson all by myself, and now you're here, so it's perfect. So I got started late because my Zoom wasn't working, but I'm going to go ahead and start right now. It's possible somebody was waiting to get in that 1 minute it took me to reboot my computer, but if they were there, they'll probably come back. So here's what we're going to do today. This is our agenda. Today's topic is all about factoring, probably the single most important skill we learned in Algebra 2, as you know. I'm going to talk about your grades for marking period 3 and marking period 4. Then we're going to go straight into factoring. The greatest common factor, the sum and difference of cubes, the difference of squares, perfect square trinomials, factor boxes, square roots, and the quadratic formula. And then I'll just barely touch on complex numbers because I don't think you really need to know a whole lot about those. And then your two assignments are the homework for Who Killed Mr. Factor. This is like that Who Killed Mr. Quad we did a while back, if you recall, where we put the things up on the wall and you had to match the answers. This one is like that. And then I'll tell you about your quizzes. So without further ado, let me talk about the grades real quick. So for marking period 4, they are going to count your grades. And if you don't do work, it's going to be a 0 this time. They told us not to put zeros in the grade book last marking period. The only zeros I put were for people who missed the test. But if they missed a quiz or homework, I didn't put zeros for those 3 weeks that we were out. Now I will be doing that. And they say if you fail the second semester, that's marking period 3 and 4 together, they're going to give you an incomplete instead of an F, and you'll have a chance to recover your grade in summer school. There's no more details on it than that. So I'm still holding off to find out how people who fail are going to get through that. And then even though we're studying for the SOL, we're not going to take it this marking period, obviously, because we're not in school. So for everybody who comes back next year, they expect you to take the SOL sometime, I think in the fall. So that's why we are studying for the SOL. Even though we're doing it now, we'll take it next year. All right, are you good?
Yes.
Okay, moving on. So GCFs, greatest common factors. If you're factoring, that's always the first step. You want to make everything as small as possible. You don't want it to be big. If you can't find a GCF, then you want to look for a shortcut. Shortcuts go really quickly like this. You don't want to do a factor box if you can do a shortcut instead. And then if you can't do a shortcut or a GCF, you want to do a factor box or use the quadratic formula. And of course, here's the quadratic formula. And you can only use it when your A, B, and C terms are all on the same side of the equal sign. So if one of these is over here, you have to pull it over. So the three of them are together. Okay?
Yes.
All right, greatest common factor looks like this. If I had these three polynomials or terms, and I looked and I said, well, let's see, 9, 3, and 18 can all be divisible by 3. That makes 3 the GCF, and you always pull it up front. Now, what comes inside these parentheses is what you get when you divide 9x squared by 3. 9x squared over 3 is 3x squared. 3x over 3 is 1x, and negative 18 over 3 is negative 6. So you never throw away the GCF. You always put it in front and then divide it out of the other 3 terms and get what's remaining. And of course, 7 goes into these 3 terms. And here, not only does 2 go into both, but so does W. So I can take the smallest variable, that's W, not W squared. But if there's no variable, you can't take any. So that's why I didn't take a P here or an X here, because there was no variable in one of the terms, so you can't take it. Are you good on GCFs?
Yes.
Okay. This is an actual SOL question. So if they asked you how to factor this, and I give you a hint and I say it involves only GCFs, which of these 4 do you think that would be?
C.
Okay, you're right that 6x is the GCF because 6 goes into 18, 12, and 6, and x goes into these 3 x terms. But then they've factored fully. And I think if you say, what is 18x to the 4th divided by 6x? Let's see who just joined us. You would get 18 divided by 6, 3. Oh, people are coming in now. Emily, nice to see you. I'm not getting any video from you, Emily. Let me see why. There you are. Hi, Emily. So 18 over 6 is 3. X to the fourth over x is x cubed. 12 over 6 is 2. X cubed over x is x squared. And negative 6x over 6x is negative 1. Okay, make sense?
Yes.
So it actually, you're right about this GCF part, but then what you get is something we can't factor anymore because you have a cube, a squared, and then no variable. So the answer to this one is D. Okay. So now let's talk about all the different shortcuts we've learned. We've learned this one first. This was the difference of squares. It's a perfect square and a perfect square separated by a negative sign. So when you take the square root, you get the square root of a squared is a and the square root of b squared is b. And because there's one negative sign with nothing else here, you have to have a negative and a positive for your two difference of squares. Make sense? Okay, so let's actually put that one into practice right now. These are perfect squares separated by a negative sign. So the square root of a squared is a, and the square root of b squared is b. You put the a in the front, the b in the back, and you put a minus and a plus. So what would this one be, do you think? What's your square root of x squared? Well, if the square root of a squared is a, what should be the square root of x squared?
So this is x in the parentheses minus 2.
Yes.
Repeat.
And then what's the other one going to be if one is x minus 2?
And another one would be plus 2.
Exactly. How about number 2? Emily, are you with me? You think you could do this one? In your head, take the square root of a squared and take the square root of 25. What is your gut telling you? All right, we'll do another one. Square root of a squared is a. Square root of 25 is 5. One of them has to have a negative sign. One of them has to have a positive sign. Not hard at all. How about square root of 16? What do you think that is? Emily, tip your screen down. I can just see your eyes and your bangs. There we go. Now I see all of you. I like your hair color, by the way. That's really bold. It's beautiful on you.
Thank you.
Square root of 16. Do you know that? You can use your cell phone. I think yep. And square root of 9.
3.
And then square root of m squared.
M.
Yes. So you get a 4 minus and a 4 plus, the 3 m's. Perfect. Okay. And then the 100 square rooted is 10, and the 49y squared is 7y, and of course you get a plus or a minus. And the 121k squared is 11k, and then 9, and you get a plus and a minus. So that was difference of squares. Then there's the perfect square trinomial where you don't have just 2 terms separated by a negative, you have 3 terms. The first and the last are perfect squares. And the middle is twice the square root of the first term and the second term, the last term. So twice the square root of a squared is a, and b squared is b. And that's how you get the answer. You say, okay, so I took the square root of a squared and I got a. I took the square root of b squared and I got b. If I multiplied these together, I get ab. And when I double them, I get twice ab. Okay? And then if the negative sign is here, it's the same exact thing, only you put a negative sign. So if you have a negative here, it goes here. If you have a positive here, it goes here, but you put parentheses around it and say squared since there's that middle term. And then the cubes, you take the cubed root of the first term and the cubed root of the last term. And the cubed root of a cubed is a, the cubed root of b cubed is b. Whatever this sign is, it's always the first sign. And then the second one is always the opposite of that. So if this is minus, this is plus. If this is plus, this is minus. And then once you know what's in the parentheses, I say, okay, I can build everything else from here. I don't even need to look back. I square this number, here it is. I square this number, here it is on the back end. I multiply the two together and I get AB. And whatever this sign is, this is the opposite. So same thing here. If I took the cubed root of A cubed and the cubed root of B cubed, I would get A's and B's. I use this sign. I square this. I square this. I multiply the two. And I use the opposite of this sign for the second sign. So that's your perfect cubes. So let's do some of those perfect square trinomials. Let's see if I can reset this page. All right, well, I've already uncovered them, so I'm just going to go ahead and talk you through them all. So the square root of 4x squared is 2x, and the square root of 9 is 3. And if I said 2x times 3, I would get 6x, and if I doubled 6x, I would get 12x, and that's the middle term. So I just say, well, I need two of these. The square root of 64x squared is 8x. The square root of 1 is 1. The middle sign is negative, so I use that here. And then I said, if I say 8x times negative 1, I get negative 8x. And if I double negative 8x, I get negative 16x, which is this middle term. And you can see this one is the same. Now down here, it looks like it's going to work, but the square root of x squared is x, and the square root of 36 is 6, and the sign is negative. But x times negative 6 is negative 6x, and if I double that, I get negative 12x, which is not this sign here, or this term. So this does not work. It looks like it would, but it doesn't. So that's why I always say do that check, because 5x times 9 is 45x, twice 45 is 90. Okay? Am I going too fast? Okay, good. And then here's your perfect cubes, the cubed root of the first term. So who knows what the cubed root of 27x cubed is? That's a little harder. So if you have a cell phone, I think it does. Actually, I don't know if my cell phone does cubed roots. I'm going to check and see right now. If I do this sideways, oh, I do see a cubed root. So I could hit cubed root of, I think I first have to hit 27 and then hit the cubed root symbol. Yep, the cubed root of 27 is 3. So right there on your cell phones. And then the cubed root of x cubed is x. And the cubed root of y cubed is y. And I told you, once you know those two terms, you just square this. So if I said 3x times 3x, I would get 9x squared. Square this. If I said y times y, I would get y squared. And then multiply the two together. If I said 3x times y, I would get 3xy. And remember, if this sign was positive, this sign has to be negative. Okay? And then that's perfect cubes with a plus sign. The next page is perfect cubes with a minus sign. So the cube root of a cubed is a. The cube root of 125 is 5. And if you square the a, you get a squared. If you square the 5, you get 25. And if you multiply these two together, you get 5a. And whatever sign was here, this sign has to be the opposite. So if this was minus, this has to be a plus. Okay? So those are your shortcuts. And then factor boxes. So let's go over how you do a factor box, because most of your homework today is factor boxing. So if you had 3x squared minus 16x plus 5, and I wanted to factor it, here's my a term, 3. You put that on the top column, on the top of the first column. Here's my c term, 5. That goes on the second column. The negative 16 hangs out on the end, because this is our check column. So what are the multiples of 3? Well, 3 and 1. And the multiples of 5, I tried a positive 5 and a positive 1, but then I didn't get to negative 16, so I went back and I made both of these signs negative. Now check across. 3 times negative 5 is negative 15. 1 times negative 1 is negative 1. These two do add up to negative 16. So once I know my check is good, negative 15 plus negative 1 is negative 16, then I read my factors this way, and this way, and you make sure you put an X in the first column. So this one would be 3x minus 1, and this one would be 1x minus 5. And if I use the zero product rule to set each of those equal to 0, I would get one of the roots is 1/3, and the other root is positive 5. So you're looking for roots today, so you would need these two numbers. Let's do another factor box. So this one is from an old work that we did earlier. So first you have to take this -15 to this side because all three terms have to be together on one side of the equals sign. So this became positive 15. So here's A, 2, here's C, positive 15, and here's B, negative 11. And you put the B on the outside. My multiples of 2 I chose for 1 and 2. And for 15, I chose a -5 and a -3 because 1 times -5 is -5 and 2 times -3 is -6, and these two do add up to -11. So my factors are, I put X's on the first column. My factors are 1x minus 3 and 2x minus 5. And if you set each of these factors equal to 0 using the zero product rule, you get X is 3. And you get X is 5/2, or 2.5. So these are the solutions right here. And that's what you need to do for your Who Killed Mr. Factor worksheet. All right, we're almost there. I'm not going to do that one. Then the rest of the worksheet is you have 20 questions. 10 of them I want you to do factor boxes on, any 10 you want. And the other 10 you can use Desmos. So if I had this as my quadratic and I typed it into Desmos, it gives me my zeros. That's a 0. And that's a 0. So I'll show you when we get to the factoring sheet. If you're looking for the solutions to this, you can go straight to Desmos. You will need to know how to do the quadratic formula. Remember, everything has to be on the same side of the equal sign for quadratic formulas and for factor boxes. So we have A, B, and C, -10. And so I put them in the quadratic formula. But while we're talking about the quadratic formula, do you recall what this part right here is called? This under the radical part? Starts with the letter D. Anybody remember the name? Nope. Discriminant. And I don't know if I'm spelling it right. That part's called the discriminant, and it tells us how many solutions. So this discriminant was a positive number. Positive numbers tell us there's 2 real solutions. Negative numbers tell us there's 2 imaginary solutions. And if it's exactly 0, you get 1 real solution. So your discriminant, the part under the radical, is the b squared minus 4ac. So here's a quadratic, 2x squared plus 20x plus 50. B is 20, so I have to square that. A is 2 and C is 50. So if I said b squared minus 4ac, I would get 20 squared minus 4 times 2 times 50 is 0. And if I get 0, it means I have 1 real solution to this problem, just 1. Here my b is 2, my a is 3, and my c is 9. So b squared minus 4ac gave me a -104. And negative numbers mean I have 2 complex solutions. And here my discriminant. B is -8 squared. Notice how I put the negative inside parentheses so that the square would hit the negative sign and the 8. I get the number 48 when I do b squared minus 4ac, and that means I have 2 real solutions because 48 is positive. It's greater than 0. Okay? And then another way you can solve, if there's no bx term where it just looks like ax squared plus there's missing bx plus c is just the constant, you can actually solve this really easily by saying, well, let's move the 200 to the other side. So 2x squared equals -200. Now let's divide both sides by 2. So x squared equals -100. And now let's take the square root of each side. And remember, when you take square roots of negative numbers, you get an imaginary. So the square root of 100 is 10. And if you have a negative sign under a square root, you have to call it I for imaginary. And we always put plus or minuses in front of the answer. All right, so these are just a quick review. These are real SOL questions from a long time ago. This one is that difference of perfect squares. Do you remember that? So what is the answer to this if you just take the square root of the first term and the square root of the second term, and one has to have a plus and one has to have a minus? Which one would you choose, Olivia?
A.
Yep. And so that's kind of like this one. So if you had the square root of x squared, you'd have x, and the square root of y squared, you'd have y, and one would have to have a plus and one would have to have a minus. So that's the same as this one. Emily, I'm going to put you on the spot. Which one of these is a factor? They didn't give us both of them. They only gave us one of them. Which one of these is a factor of this?
G.
Which one?
G.
G is correct. Well done, you. Okay. And then there's some more. And so here's a perfect cube. The cubed root of 1 is 1, and the cubed root of y cubed is y. So I know I have a 1 and a y. And this middle sign always has to go in the first one. So it's either F or G. It can't be this one or this one. But then you have to square the 1. 1 squared is 1. Square the y squared is y squared. Y squared is y squared. And then multiply 1 times y. But remember, the signs have to be different. If this is negative, this has to be positive. Well, that's negative, that's positive. And the last one is 100 times 100% positive. So that one would be G. Okay? And let's move on. So here we need some factor boxes. So I would put the 6 here. What goes here, the 7 or the negative 3?
Negative 3.
Negative 3. The 7 hangs outside. So let's see, 6, if I look at the answers, it's either going to be a 2 and a 3 or a 6 and a 1. What's your guess?
2 and 3.
All right, let's try a 2 and a 3. That's a good guess. And then for 3, it's either 1 and 3 or 3 and 1. Nope, that's not going to work. Oh, yeah, it might. Okay, so one of these has to be negative, so let's make the 1 negative. So 2 times negative 1 is negative 2, and 3 times 3 is 9. And if I add 9 plus negative 2, I do get 7. So that means our factor box is right. So now all we have to do is go through and put x's on them and read them diagonally. This one is 2x plus 3, and this one is 3x minus 1. Ah, seems like all the answers have been the first answer so far. Oh, except Emily's. Emily's was G. Okay, that's enough on factoring. So this is one of those where they want the discriminant, so you move everything to the same side. So I moved the 6x over and the negative 1 over, and then I did b squared minus 4ac. So b was negative 6 squared, a was 9, c was 1, and I got 0. How many solutions do you get if you have a 0 for your discriminant? Is it 1 real, 2 distinct real, 1 imaginary, or 2 imaginary?
A.
It is 1 real. Very good. All right. Complex numbers I'm going to show you super quick because your calculator will do all this for you. So if you make sure you're in the mode that is a plus bi, come on, mode. How weird. My calculator's not working. Well, I'm going to have to skip this part because my calculator's not working unless I can get it to work. Let me try this. Still not working. How weird is that? All right, we will skip that part because you don't need to see it, but on the TI you can do it if you use the second decimal for the I key. And that brings us to the assignment for Who Killed Mr. Factor. So there's a link in your Google Classroom. If you go to Google Classroom, there is a link that says, it says Who Killed Mr. Factor. Come on, go back. And this link takes you to the game, and the game looks like this. It's got the worksheet. You have to solve 10 of these using factor boxes and 10 using Desmos. You can choose any 10 you want. And then it'll ask you who killed Mr. Factor with what in the where. And so here's how that game goes. We're going to do the first one. You get these choices for the who, what's, and where's. And when you eliminate one, whoever's left is the answer. So if I checked off Jones, Brown, Patrick, Mans, and Wright, Mrs. Davis would have to be the answer. You guys have played this before. So here's the first one. I'm going to do a factor box, but you could choose to do Desmos or a factor box, but you have to do 10 of each. 2, -9, and 3. So the factors of 2 are always 1 and 2. -9, I'm going to try -3 and +3. 1 times -3 is -3. 2 times 3 is 6. If I add 6 to -3, I get 3. So I know my factors are right. So I say 1x plus 3, and I say 2x minus 3. So 1x plus 3 and 2x minus 3. And you have to use your two factors to get your zeros. So I set this factor equal to 0. So if I say x plus 3 is 0, then x must equal -3. And if I say 2x minus 3 equals 0, x has to be 3/2. And you can write that out step by step. So now I have to go into my worksheet and find where there's a -3 and a 3/2. And right there is a -3 and 3/2. So I would check off the garden. That's not where the murder happened. Got it? All right, so that's how I do it with a factor box. I'm going to do one with a Desmos. So I went to Desmos and I typed this in exactly in my Desmos. And it crossed the x-axis at 0.563 and 1. Well, 0.563 is a rounded number. They don't always give you the exact answer here. They take it to 3 decimals. So I need to go back to that worksheet and find the closest to a 0.563 and a 1. So what I'm going to do is a little bit of sleuthing here. I'm going to say, where does a 1 show up? Well, that's a 1, but it's negative, so it can't be that one. Oh, here's a 1, and here's a 1. So I know the 1 is correct. Now, the other one has to be a 0.563. Is -1/3 that, or is 9/16? So if I go to Desmos, I can say -1/3, which you knew was going to give you 0.3s repeating, and 9/16. No, 9/16. And that looks like it rounds to 0.563. So I know the 9/16 is correct. So I can go back and say it's this one, not this one. So the balcony is also wrong. So of all the wheres remaining, you can go through the dining room or the hall, down to the hall, the crowbar down to the vase, and Mr. Jones down to Miss Davis. One of these did it in each box. And when you get to that, you're going to actually type it in. Who, what, and where. Please type it in exactly as it shows here with the capitals and everything, because if you don't get it exactly typed right, it tells you you're wrong, even though you might be right. Okay? And then when you're done with all of that, you're going to go to your quadratic equations quiz for factoring. And this is your code, 2444319. So you have till Friday. I gave everybody till April 18th to do all of this work, but I hope you don't wait until the last minute, because we're also meeting on Thursday and I will give you something to do then as well. Everybody good?
Yes.
Okay. That's all I have for you. If you have any questions, either email me or give me a quick, you can put something in Google Classroom and it'll come to me that way too. You can do a comment there. And I will see you guys Thursday, I hope. Bye.
Bye.